In this video, I'm going to solve this Bernoulli differential equation. A Bernoulli differential equation has the following structure: dy over dx plus p of x times y is equal to q of x times y to the power n, where n cannot be equal to 0 or 1. If n is 0, it becomes a linear differential equation, first order, which is solvable by integrating factor. And if n is equal to 1, this becomes a separable equation that could be solved by separation of variables. If n is anything other than 0 or 1, then we have a Bernoulli differential equation. In our particular example, look here, n is equal to 2. To solve this Bernoulli equation, I need to divide both sides of this equation by y square. That's going to give me 1 over y square dy over dx plus x cube times 1 over y is equal to x cube. Now I'm going to make a small substitution, and that substitution will be this. I'm going to assume that z is equal to 1 over y. So that is going to be my z. So that gives me dz over dx is equal to negative y to the power negative 2 dy over dx. If I simplify it further, that's going to give me dz over dx is equal to 1 over y square times dy over dx. Now if you notice that this is the same as this, so I could replace this by negative dz over x. Negative dz over, dx. So upon simplification, I get negative dz over dx plus x cube times z is equal to x cube. If I multiply both sides of this equation by negative 1, that gives me dz over dx plus, actually it's minus x cube times z is equal to minus x cube. This is what I get. Now, this is nothing but a first order linear differential equation that I could solve by using integrating factor. So my integrating factor is going to be mu of x is equal to e to the power integral p of x dx. My p of x is the coefficient of z. That's going to give me e to the power integral negative x cube dx, which is going to be e to the power negative x square over, x to the power 4 over 4, because x cube integral of it, x to the power 4 over 4. Now I'm going to multiply both sides of this equation by, both sides of this equation by e to the power negative x to the power 4 over 4. If I do that, I get e to the power negative x to the power 4 over 4 times dz over dx minus x cube z times e to the power negative x to the power 4 over 4 is equal to negative x cube times e to the power negative x to the power 4 over 4. And the left hand side, by the way, is nothing but the derivative of d over dx z times e to the power negative x to the power 4 over 4. All right. And the right hand side is just right hand side, right? Negative x cube e to the power negative x to the power 4 over 4. Now, at this point, I can go ahead and integrate both sides of this equation with respect to x. So dx, integrate this with respect to x dx. On the left side, by the way, I'm going to get z times e to the power negative x to the power 4 over 4, right? And on the right hand side, I have to do the integral. To find this integral, it's not really that bad. It's pretty easy. Integral x cubed e to the power negative x to the power 4 over 4. So what I'm going to do, I'm going to do a u substitution. Let's say u is equal to negative x to the power 4 over 4. That gives me du over dx is equal to negative x cubed, or du is equal to negative x cubed dx. Equivalently, this is going to be negative du is equal to x cubed dx. So if I go back into the original integral, I should have a dx here, by the way. So if I go back to the original integral, I will have integral x cubed dx is negative du, right? Then e to the power u, because my u is this, so which is going to be negative integral e to the power u du, and that's nothing but negative e to the power u, that is negative e to the power negative x to the power 4 over 4. So that's gonna give me, oh, okay, so here it is negative, and negative is gonna make it positive, so that's gonna be e to the power negative x to the power 4 over 4 plus the arbitrary constant c. Now if I simplify it a little further, I have to multiply both sides of this equation by e to the power x to the power 4 over 4 to get rid of this one on the left. So that's going to give me z is equal to, this is going to be 1 plus c times e to the power x to the power 4 over 4. Okay, remember x to the power 4, e to the power x to the power 4 over 4 times e to the power negative x to the power 4 over 4 is going to give you e to the power 0, which is just 1. Now, z is, however, equal to 1 over y. So I'm going to put 1 over y is equal to 1 plus c times e to the power x to the power 4 over 4. Or if I solve for y, it's going to give me y is equal to y of x is equal to 1 divided by 1 plus some arbitrary constant c times e to the power x to the power 4 divided by 4. And that should be your final answer. So that is the solution to this Bernoulli differential equation. I hope that this discussion was helpful. Thank you very much.